Woohoo! Mr. Wernau back here. We're going to do some of your homework questions with you. So I'm going to take a look at number 10 right now. And this is the one where we want to graph the original function, given the derivative. Now earlier this year we talked about the one thing you need the most is some points. So the question is, if I'm given the derivative, how do we go back and get the points or the values? And of course the answer is to integrate these. So we're going to need to take some antiderivatives. So but first, let's go through here. Now they're telling us the area of region 1 between 0 and 2 is 2. And the area between 2 and 6 is 7. But you got to remember that's really saying it's a negative 7. We're just going to scratch it out, put a negative there. And the area from 6 to 8 is 4. Now we've done these before. The only difference is that now we have to actually go ahead and find the end to get the area. Now they do tell me the initial value at 2 is 3. So I know that f of 2 equals 3. Well, I can use that to find the value at 0. So I'm going to go ahead and find the value at 0. Well, again, since they give me the derivative, I am going to integrate. The area between 0 and 2 of f prime of x dx. Now, if I use the fundamental theorem, this is going to be f of 2 minus f of 0. Now, I know this region right here is that area is 2. And remember, it's telling me between 0 and 2, the values are increasing by 2. F of 2 is 3 minus f of 0. So let's just think about what this means again. We're saying that the values between 0 and 2 are increasing by 2. That's what that area tells me. If I'm ending up at 3, well, where was I at the beginning? Well, if I increase by 2, it should put me at 1, and which is what this does give us. F of 0 equals 1. So I have another point. Next, I can find the value at 6, because that's another critical number. So basically, you're going to look for those critical numbers. So you want the critical numbers. So f of 6, to get that one, now I'm going to look at the area between 2 and 6. So between 2 and 6, we know we decreased in value by 7. Well, if you think about it, if I'm starting at 3 and I'm decreasing value by 7, it should put me at negative 4. So let's see if it works using calculus. Using my fundamental theorem, we get f of 6 minus f of 2. And let's see here, we know that this is negative 7. F of 6 is what I want, minus f of 2, which they tell me is 3. Up there it is. F of 6 is indeed negative 4. So now I got 3 points, and I can get one more at 8. So I can almost do these in my head. Between 6 and 8, we're increasing by 4. Well, where should that put us? If I'm starting at 4, and I increase by 4, we should get 0. So let's see if that works. The area from 6 to 8, f prime of x dx, using the fundamental theorem, this is going to become f of 8 minus f of 6. The area here, of course, is negative 4, equal to f of 8, which is what I want, minus f of 6, which is a negative 4, makes that a plus 4. So f of 8 equals 0. So we got a bunch of points right now, right? So after we get the points, then we needed the critical numbers. We need to get the shape of the graph. So we need to find those maximum and minimum values. So to do that, we look at the critical numbers. Since this is my derivative, the critical numbers are easy. X equals 0, 2, 6, and 8. And let me see here. If I do my sign chart, I'm going to do my sign chart here. 0 to 8, f prime and f, 2, 6, nope, there it is. So I look at the signs. I'm above, below, and above. So plus, negative, plus. So it's increasing, decreasing, increasing. So I know I have a maximum at x equals 2, and I have a minimum at x equals 6. So I can start sketching my function right now. So let's see here. Hopefully you can kind of see that right there. Ignore all that. So if I start sketching my function, ready? Let me see here. My points are 2, 3. So if I go over 2, up 3, there's 1 point. And I already know that that's the maximum value. I have another point at 0, 1. Another point at 6, negative 4, 1, 2, 3, 4, 5, 6, down 4, 1, 2, 3, 4. And I know that that's a minimum value, because remember, here because f prime goes from positive to negative, and here because f prime goes from negative to positive, and I have one more point at 8, 0. There we go. So the graph kind of looks like this. Remember we graphed these before. Kind of looks like this, right here. And the only thing right now is the shape of the graph. So I need the points of inflection. To do that, we need where the second derivative is equal to 0, or d and e. And remember, we are going to look at the slopes of f prime of x. So where do my possible points, I guess I should say possible points of inflection, and they are, looking at the graph, here, which is at 1, whoop, wrong graph, let's do this one, wrong one, here, which is at 1, down here at 4, and over here at 7. That's what we're looking for. So I'm going to do my sign chart from 0 to 8, f double prime and f, 1, 4, 7. Remember, I'm looking at the slope of f prime. So positive, negative, positive slope, negative slope. So positive, negative, positive, negative. Concave up, concave down, concave up, concave down. So I have POIs at x equals 1, 4, and 7. And that is because the second derivative changes sign. That's all you need to put. So at 1, I'm going to put a POI. At 4, 1, 2, 3, 4, put a POI. That's why I draw that dashed line. Makes it a little bit easier. And at 7, a POI. And now I just need the curvature. On 0 to 1, we are concave up. So, and everything else it switches. Concave up, concave down. Be careful, don't make another maximum. We talked about that. Concave up, and then concave. Be careful. I'm going to make this concave down, but I'm not going to loop over, because otherwise I'd be creating another maximum, which isn't listed. And there's our graph. These are hard to do. These take a while to do, but you want to practice these because these really will help you understand the derivatives and the relationship with the fundamental theorem of calculus right there. All right, we did that one with you. That was a fun one right there. And now let's take a look at number 15 here. This came up on the AP test a few years back. Given the graph of the derivative, so this is a derivative graph, I'm going to identify it as, which consists of the line and the semicircle. Given f of 1 is 4, let's just do part A, find f of negative 2. So here's that negative 2. So I'm looking at the area. This is an FTC problem right here. So to solve this one, if I want to find the value of 1, given my derivative, I have to integrate the area from negative 2 to 1. I like to go in order. F prime of x dx, that's going to equal f of 1 minus f of negative 2. Well, to solve this, I'm just looking at the area between negative 2 and 1. So I'm going to look at those areas. Now be careful, this one's below. So this is going to become negative 1/2. The base is 2. The height, 1, 2, 3, 4, is 4. I keep my negative on the outside because it's below. Plus this area here, 1/2, the base is 1, and the height is 2. And if I simplify that, that gives me negative 4 plus 1, and that's going to equal f of 1, which I know is 4, they tell me, minus f of negative 2. So if I were to solve this one, what's that? Negative 3 equals 4 minus f of negative 2. F of negative 2 equals, what's that? Negative 7 becomes 7 right there. So that's just 7. I'll let you guys go do the next one. You do it through a circle, and we'll tell you this, the easiest way to do it is rectangle minus circle in terms of area. Alright, last one I want to take a look at with you guys right here. I'll let you guys do that one. That's kind of not too bad of one. That's just like we've been doing. If the graph of f of x is defined by this, f of x equals x cubed plus 2, and g is the antiderivative of f such that g of 3 is equal to 5, so then find g of 1. Alright, so really tough thing to do. Basically they're saying g is the antiderivative of f. So what they're really saying is that f here is g prime of x. Just rewrite that, okay? They're going to try to mess it up. If they say g is the antiderivative, then they're saying g of x is my function, so therefore f has to be my derivative. So this is a typical FTC problem. So this is a calculator question, because we'll see why in a second. So this says we want to find 3, but we're looking for 1, so we go from 1 to 3. G prime, which is this x cubed plus 2 dx, that's going to equal g of 3 minus g of 1. AP loves to do these on the questions where they switch variables on you. When we get to second FTC, we'll talk more about that. We cannot integrate this one, so we're going to use our ever-trusting calculator or your math tool online. Menu for an integral from 1 to 3, and we're just going to type it in, the second square root of x to the third plus 2 dx. Press enter, and it gives me 6.585. So 6.585. We can't integrate this one by hand, so we have to use a calculator. And that's going to equal g of 3, which they tell me is 5, minus g of 1, and just using a little bit of calculus, a little bit of math, minus the 5. Be careful, I do have to change my sign, so we should get g of 1 is negative 1.585. And the answer, of course, is B. Alright, I hope you guys enjoyed these. I did. I'll see y'all later. Bye-bye.